On the 1st of July 2025, sky surveys picked up something extraordinary. A faint, fast-moving object, unlike what we usually track in our solar system. It was named 3I, Atlas III confirmed object ever seen that came from outside our solar system. Today we'll dive into what it is, why it matters, how it behaves, and what we may learn from it. In 2025, astronomers using the Asteroid Terrestrial Impact Last Alert system made a remarkable discovery. While scanning the skies from observatories in Chile and Hawaii, the system detected a faint, fast-moving object far out in the solar system. At first, it looked like a distant comet or asteroid, but its path through space revealed something extraordinary. Unlike normal solar system bodies which follow elliptical orbits around the sun, this object was traveling on a hyperbolic trajectory, meaning it wasn't bound to the sun's gravity at all. It had come from deep interstellar space, passing briefly through our cosmic neighborhood before heading back out forever. This object was officially designated 3I, Atlas 3I, for the third interstellar object ever discovered, following 1I Oumuamua in 2017 and 2I Borisov in 2019. The name Atlas honors the telescope survey that found it. Each of these interstellar visitors has given scientists a unique glimpse into the materials and forces at work in other star systems far beyond our own. With 3I, Atlas, humanity once again has the rare chance to study an object that formed around another star long before our sun was born. Oumuamua, the first, was a mystery, a cigar, or pancake-shaped rock that defied easy explanation. It showed no tail or gas emissions but accelerated slightly as if pushed by sunlight. 2 years later came Borisov, the second interstellar visitor, which behaved much more like a normal comet with a bright tail of gas and dust. Now 3I Atlas appears to be somewhere in between, potentially a faint, inactive comet, but with the same telltale hyperbolic path confirming its interstellar origin. What makes 3I Atlas so fascinating is not only its trajectory, but what it represents. Every interstellar object we detect is a physical fragment of another planetary system debris ejected during the chaotic early days of planet formation around another sun. Over millions or even billions of years, such fragments drift through the Milky Way, crossing the vast gulfs between stars. The fact that Atlas has now found one means our solar system is not isolated. It's part of a galactic traffic stream of wandering material quietly passing by in the darkness. Scientists are now using every available telescope to observe 3I Atlas while it remains visible. Its brightness, color, and spectrum can reveal clues about its composition. Whether it's rocky or icy, pristine or weathered by cosmic radiation, these details help astronomers compare it to Oumuamua and Borisov, building a growing picture of what other star systems might look like. Each new interstellar visitor is like a messenger from beyond, carrying chemical fingerprints of its home world. Unlike asteroids or comets that circle the sun indefinitely, 3I Atlas will visit only once. After looping past the inner solar system, it will continue on its open trajectory heading back into the dark interstellar void. Humanity will never see it again, but the data collected during its brief encounter will deepen our understanding of how common these visitors might be and what they tell us about the universe beyond our Sunday. In just a few years, we've gone from believing interstellar objects were theoretical to discovering 3 of them in real life. With upcoming surveys like the Vera Rubin Observatory's Legacy Survey of Space and Time, LSST, astronomers expect to find many more. Each discovery brings us closer to understanding the cosmic pathways that connect star systems and perhaps, one day, the origins of life itself. The discovery of 3I, Atlas, is far more than just another astronomical find. It's a window into the wider galaxy. Interstellar visitors like this are extremely rare, and every one we detect is an opportunity to study something that didn't originate in our own solar system. For centuries, humanity's understanding of the universe has come mainly from what we could see and touch within the sun's domain: planets, asteroids, and comets bound to our star. But an interstellar object breaks that boundary. It's a piece of another star system ejected long ago and now drifting through space until chance brings it near us. Studying 3I Atlas allows scientists to examine for the first time matter that was forged in an environment entirely different from our own, a literal messenger from another world. Each interstellar visitor offers a direct sample of alien material, not alien in the science fiction sense, but alien in origin. Its composition, density, color, and activity reveal the chemical fingerprints of the star system it came from. By comparing these clues to what we know about comets and asteroids here at home, astronomers can see how typical or how unique our solar system really is. In other words, 3I Atlas gives us a kind of cosmic mirror, a way to compare our neighborhood to those light years away. It helps scientists test their theories about how planets form, how debris gets ejected into space, and what the building blocks of other worlds might look like. What makes 3I Atlas particularly intriguing is that it seems to be active. As it approaches the Sun, it shows signs of outgassing, releasing gas and dust just like a comet. That's something we didn't see with Oumuamua, which stayed oddly quiet. This activity gives researchers a chance to study its physical and chemical makeup in greater detail. By analyzing the gases it releases, scientists can determine what kinds of ices or minerals it contains and how those materials differ from the comets and asteroids native to our own system. In a way, it's like getting a free sample of another star's leftovers carried across the galaxy for millions of years and delivered right to our doorstep. But beyond the chemistry and physics, the true importance of 3I Atlas lies in the questions it raises. How many of these interstellar objects are there? How often do they pass through our solar system without being noticed? Could some of them carry the organic ingredients, carbon, water, complex molecules that contribute to life elsewhere in the universe? Each discovery forces us to think on a larger scale, to imagine the galaxy not as a collection of isolated stars, but as an interconnected ecosystem where materials and maybe even the seeds of life travel freely between worlds. The appearance of 3I Atlas also highlights how far our technology has come. A few decades ago, such objects would have passed unnoticed. Now, with advanced survey systems like ATLAS, PanSTARRS, and soon the Vera Rubin Observatory, we're beginning to spot these fleeting visitors with enough time to study them before they vanish. Every new detection refines our understanding of how common these cosmic travelers are and prepares us for future missions that might one day intercept and study one up close. In the grand story of astronomy, 3I Atlas is another chapter in our awakening to the living, dynamic nature of the galaxy. It reminds us that our solar system is not isolated but connected, part of a vast network of stellar systems exchanging debris, dust, and perhaps even the raw materials of life itself. Through this single passing object, we are reminded that we too are part of a greater cosmic story, one that stretches far beyond the sun into the endless dark between the stars. Every interstellar object that passes through our solar system is more than just a curiosity, it's a lesson from the galaxy itself. 3I Atlas, like its predecessors, Oumuamua and Borisov, gives scientists a rare opportunity to test their understanding of how planetary systems form and evolve. Most of what we know about space comes from observing our own solar system, but 3I Atlas represents a sample from somewhere else entirely. It's a piece of cosmic evidence, a fragment of another sun's debris, sculpted by forces we can only imagine. By studying it, astronomers can begin to answer one of the most profound questions in modern science. How typical is our solar system compared to the rest of the galaxy? Spectroscopic studies analyzing the light reflected and emitted by 3I Atlas can reveal the chemicals that make up its surface and gases. These signatures tell us what kinds of elements or ices exist beyond our star's reach. For example, if 3I Atlas contains compounds like carbon monoxide, methane, or ammonia in unusual ratios that could suggest it formed under very different conditions, perhaps around a smaller, cooler star or in a system rich in heavy elements. Every molecule it releases into space becomes a clue about its birthplace. It's like examining a message written in the language of chemistry, carried across the galaxy for millions of years. The object's shape, brightness, and spin can also teach us about its past. By observing how its light fluctuates, scientists can estimate how it tumbles and whether it's solid, fractured, or coated in dust. These details help reconstruct the violent processes that might have ejected it from its home system, maybe through a planetary collision or a gravitational slingshot from a giant planet. In essence, 3I Atlas may hold the story of another world's destruction in its journey through the interstellar void. Another exciting lesson lies in the object's interaction with sunlight. As it approaches the sun, its surface heats up and releases gases. By tracking how its motion changes, researchers can test how sunlight and radiation pressure influence small bodies traveling through space. This knowledge doesn't just help us understand interstellar objects, it also refines our understanding of comets, asteroids, and spacecraft propulsion in our own system. Finally, 3I Atlas teaches us something even deeper about our place in the cosmos. Its mere existence shows that materials constantly flow between stars, connecting distant systems in an invisible web of exchange. The same dust and ice that built 3I Atlas could someday seed another planet, perhaps even another civilization. Each visitor reminds us that the universe is not still or isolated, but alive with motion, a vast ocean of stars and worlds whose stories occasionally drift across our path. The discovery of 3I Atlas isn't just another entry in astronomy's record books, it's a sign of what's coming next. With each interstellar visitor, we're learning how to spot them faster, track them better, and maybe one day even reach them. New survey telescopes like the Vera Rubin Observatory in Chile will soon scan the sky every night, capturing data on millions of moving objects. When the next interstellar traveler enters our solar system, we'll be ready. Space agencies like NASA and the European Space Agency are already designing missions such as the Comet Interceptor, a spacecraft built to launch toward any newly discovered object passing near Earth. If it's fast enough, it could one day chase an interstellar visitor, capturing close-up images, sampling its gases, and revealing what these alien travelers are truly made of. 3I Atlas reminds us that our solar system is not alone, it's part of a much larger galactic ecosystem. Every passing object is a story, a relic, a traveler carrying information from another star. And with each discovery, we move a little closer to understanding not just where we are in the universe, but how connected we truly are to everything beyond it. Finding interstellar visitors like 3I Atlas is far from easy. These objects are usually small, faint, and incredibly fast, racing through space at tens of kilometers per second. By the time they're close enough to detect, they're already moving away. Oumuamua, for example, was only spotted after it had passed the sun and was already leaving the solar system. That means astronomers have just a short window, sometimes only weeks, to study these cosmic travelers before they disappear forever. 3I Atlas was discovered earlier in its approach thanks to improved technology and wider sky coverage. Systems like Atlas, Pan-STARRS, and Catalina Sky Survey continuously scan the skies for moving points of light. Each image is compared with previous ones, allowing computers to spot any object that shifts its position, a sign that it's something new and nearby. When astronomers realized that 3I Atlas's orbit wasn't curved like a normal comet's, but open and hyperbolic, they immediately knew it came from beyond the solar system. Future discoveries will depend on how quickly we can detect and analyze such trajectories. With the Vera Rubin Observatory coming online, we'll soon be able to scan the entire visible sky every few nights, capturing billions of data points. Artificial intelligence will help process those images, flagging anything unusual in real time. The goal is to spot the next interstellar object early enough to study it in detail, maybe even to launch a probe to meet it before it slips away into the dark. When astronomers discover a new object in the sky, the first thing they do is calculate its orbit, how it moves under the sun's gravity. For most comets and asteroids, that orbit forms an ellipse, meaning it's closed and bound to our solar system. But for 3I Atlas, the data showed something different. Its path was a hyperbola, an open curve that will never close back on itself. In simple terms, that means it came from outside the sun's gravitational influence and will never return. That hyperbolic trajectory is the cosmic fingerprint of an interstellar traveler. The second clue comes from its speed, 3I. Atlas is moving faster than any object bound to the sun could naturally travel. Even accounting for the sun's pull, it's moving at tens of kilometers per second relative to our solar system, far too fast to have formed here. This velocity matches what astronomers expect from objects drifting through the Milky Way, pulled and pushed by the gravity of many stars over millions of years. Once its interstellar nature is confirmed, scientists turn to spectroscopy, breaking down the light it reflects and emits into its component colors. This reveals the chemical composition of the object's surface and gases. By comparing those spectral lines to those of known comets and asteroids, researchers can tell whether its materials are similar to ours or completely alien. For example, if 3I Atlas shows unusual ratios of carbon, oxygen, or nitrogen, that could suggest it formed in a different kind of star system, maybe around a red dwarf or in a colder, more distant region of its home nebula. Together, these clues, its orbit, its speed, and its chemistry form a complete picture of its journey. From these, scientists can trace where it came from, how it was likely ejected from its original system, and even how long it's been traveling between the stars. 3I Atlas isn't just a piece of rock and ice, it's a time capsule carrying a record of processes that took place light years away, long before our planet ever formed. To understand where 3I Atlas began its journey, we have to look far beyond our solar system into the early chaos of planetary formation. Around young stars, massive disks of gas, dust, and ice swirl in orbit, slowly clumping together to form planets, moons, and comets. These regions are turbulent, with constant collisions and gravitational interactions between growing worlds. Sometimes those encounters are violent enough to fling debris completely out of the star's system. That's how scientists believe interstellar objects are born, not through quiet drifting, but through cosmic chaos. Imagine a developing solar system billions of years ago. A large planet forms, its gravity disturbing nearby comets and asteroids. One of those objects strays too close and gets slingshotted into deep space, propelled fast enough to escape its star's gravity forever. Once it leaves, it becomes a wanderer, an interstellar traveler like 3I Atlas, drifting endlessly between the stars. Over eons, these ejected fragments spread throughout the Milky Way, creating an invisible river of debris that occasionally passes through systems like ours. Astronomers believe that 3I Atlas may have started in just such a system, perhaps orbiting a distant star that has long since aged or even died. As it traveled through space, it would have endured cosmic radiation, micrometeorite impacts, and temperature extremes, slowly changing its surface. By the time it entered our solar system, it had likely spent millions, maybe billions of years in interstellar space, untouched and frozen, until gravity pulled it close enough for us to see. What makes these objects so valuable is that they carry the original material of their parent systems. Studying them allows scientists to compare how other stars form planets compared to ours. Were their comets made of the same ices and minerals? Did they contain the same organic compounds? Each interstellar object gives us another piece of that puzzle, another hint about how planetary systems across the galaxy evolve, collide, and share their remnants. The discovery of 3I Atlas raises a question as old as humanity itself. Could life or at least the ingredients for life, travel between the stars. Scientists have long wondered whether the building blocks of biology, carbon, water, amino acids, and organic molecules, might be spread throughout the galaxy on comets, asteroids, and interstellar debris. Objects like 3I, Atlas, may be part of that grand exchange. As they drift from one star system to another, they carry with them the raw materials that make life possible. We already know that many comets within our own solar system contain complex organic compounds, including the same kinds of molecules found in living cells. If 3I, Atlas, and others like it formed around distant stars, they could be carrying similar ingredients, perhaps even richer varieties shaped by different cosmic environments. When these objects pass near stars or crash into planets, they may deposit traces of those compounds, seeding new worlds with the chemistry of life. This idea, known as panspermia, suggests that life on Earth might not have started here at all. It could have arrived from elsewhere, carried by visitors from the depths of interstellar space. While there's no direct proof of that yet, 3I, Atlas offers scientists a rare opportunity to test the theory. By studying its chemical makeup, astronomers can determine whether the organic molecules we find are unique to our solar system or common throughout the galaxy. If they turn out to be universal, it would mean that the seeds of life exist everywhere, scattered among the stars, waiting for the right planet to take root. In that sense, 3I, Atlas is more than just an astronomical discovery. It's a reminder that the universe may be deeply connected. Every interstellar object that passes through our skies could carry a small piece of another world's history, or perhaps a whisper of life's beginning somewhere far away. The discoveries of Oumuamua, Borisov, and now 3I, Atlas, have transformed astronomy. They've shown us that interstellar visitors aren't once-in-a-lifetime events. They might pass through our solar system more often than we ever realized. The challenge now is being ready when the next one arrives. For scientists, 3I, Atlas, is not just an object of study. It's a wake-up call to prepare for the future of interstellar research. Upcoming technology promises to change everything. The Vera C. Rubin Observatory, set to begin full operation soon, will scan the entire night sky every few nights, capturing images of billions of celestial objects. With its powerful data systems and AI analysis, it could detect the next interstellar visitor months, maybe even years, before it reaches the inner solar system. That extra time would allow space agencies to plan and launch a mission to intercept it while it's still close enough to study in detail. Projects like NASA's Comet interceptor are already being designed for that exact purpose. It's a spacecraft that will wait in space till a suitable target, perhaps even another interstellar object, is discovered. When that happens, it will launch toward the visitor, capturing high-resolution images and analyzing its gases and dust directly. Such a mission could give us our first close-up view of material from another star system, a glimpse into the chemistry of another corner of the galaxy. Other proposals go even further, imagining dedicated interstellar intercept missions to robotic probes that could be launched on short notice using high-speed propulsion systems. Some scientists even suggest using solar sails or nuclear propulsion to reach these fast-moving travelers before they escape into the darkness again. Each new visitor, like 3I, Atlas, reminds us that we're not isolated in space. Our solar system is part of a much larger galactic neighborhood filled with motion and mystery. And one day, when we finally intercept and study an interstellar object up close, we might uncover secrets that reshape everything we know about how stars, planets, and even life itself are connected across the cosmos. As 3I Atlas continues its silent journey through the vastness of space, it reminds us of something profound: that the universe is not a distant mystery, but a living, breathing ocean of worlds and wanderers. Each interstellar visitor that passes by carries a story billions of years in the making, written in dust, ice, and starlight. These are messages from the galaxy itself, a fragments of forgotten systems drifting between the stars. With every discovery, we take one small step closer to understanding our place in that cosmic story. We begin to see that our solar system is not an island but a single wave in a boundless sea. And as we prepare for the next interstellar traveler, we carry with us the same feeling that has always driven exploration, curiosity, wonder, and the desire to know what lies beyond. So, if you love exploring the unknown and diving deep into the mysteries of the universe, make sure to like this video, subscribe to the channel, and hit the bell icon so you never miss another journey among the stars. Because out there, beyond the sun's glow, the next cosmic visitor is already on its way, and when it arrives, we'll be ready to meet it.